all of you dear NEET aspirant. Today we study that stereoisomerism. For that topic is classified in two type. One is a configurational isomerism. Okay, configurational isomerism or configurational analysis. Another one is a conformational analysis. Okay, so for this configurational isomers, again classified in two types. One is for that geometrical, okay, geometrical isomers. Another one is for optical isomers. In generally, this configurational analysis, here no CC bond rotation, okay. But in the case of here, there's a CC bond rotation is occurred. CC bond rotation. Here we get in that the stability of the molecules, especially studied. There is a Kite's conformer, anti-conformer, staggered, fully eclipsed. So that kind of molecules we studied here. This conformational analysis is better for we will study this subtopic next video. Okay. So today, these two geometrical and optical isomerism we will study in this unit of some basic for GOC. Okay. Okay. So now the geometrical isomerism. This is the first case. There is a geometrical isomerism. So geometrical isomerism, one thing you keep your mind in generally that isomers are showing the unsymmetrical alkene as well as cycloalkanes, okay, because the cycloalkanes means there is a unsaturation is there. So for that cycloalkane and alkene, if showing that unsymmetrical alkene or unsymmetrical substituent, that is must be showing the geometrical isomerism. Okay, so what are that geometrical isomerism name is for cis and trans. Okay, and a second category E and Z, and a third one that is for syn and anti-conformer. Okay, and a fourth one for there is a what exo and endo. Only in these four types are presented in that geometrical isomerism. Especially in our higher secondary level or NEET level, this cis and trans and E and Z isomers representation, that is the most enough for a NEET aspirant. Okay, so remaining these two is also there. You know. Okay, these are the basic geometrical representation isomerism. Okay, so now we go to that one by one. First of all, the cis trans isomers. How we say there is a cis and trans isomers. This cis trans isomers, the substituent are similar, at least a minimum two substituent are similar, then only we go to that there is a cis trans isomers. Okay, here there is a at least minimum there is a two substituent are same, so then only we say that is a cis and trans isomers. For example, in the case of geometrical isomers are showing the unsymmetrical alkene or unsymmetrical substituent of there is a cycloalkane. The alkene means there is a unsaturation. Actually, there is a unsaturation, okay, directly proportional to for elimination of hydrogen. Okay, elimination of hydrogen. So that is for nothing but the unsaturation increases. So that's why the cycloalkanes also their unsaturation possesses some percentage of unsaturation. That's why I'm saying the cycloalkanes also is showing the geometrical isomerism. Okay, first of all, that alkene, there's a carbon, double bond carbon, hydrogen, there's CH3, hydrogen, CH3. So there is nothing but, according to IUPAC name, there is a butene. Okay, okay. So here the hydrogen and hydrogen, the adjacent carbon of substituent are same side, or this methyl and this methyl are same side for that carbon or adjacent. So that's why there is a cis isomers. Okay, okay. So the same group or atoms or if substituted at the same side, that is the cis isomer. The opposite side of that same atom is substituted, that is for the trans isomers. Okay, so here the methyl and methyl are opposite direction, so that is a trans isomers. Okay, so trans isomer, this is for the cis isomers. Okay, so simply saying that at least minimum two same substituent of adjacent carbon, there is a same side, there's a cis, or opposite side, there's a trans. Okay, okay. So the geometrical isomers or unsymmetrical alkanes. That's a very very important key point. Okay, so next, E and Z isomerism. E and Z isomerism. For this E and Z naming representation, here following that, the substituent of alkene all must be different. Okay, substituent of alkene all must be different, must be differ. Okay, so then only we go to that E and Z isomerism. Thereafter, whether that compound or E or Z in nature, we can find out the priority order of that group. So here using Kahn-Ingold Perlog rule. Kahn-Ingold Perlog rule. Okay, this rule is also applicable for that optical isomerism. This rule what say? The higher atomic number, higher priority. There is a higher atomic number or first priority. Okay, so here after that the atomic number decreases, then the priority also decreases. Then if same atom, if same atomic number but mass differ. Okay, for this mass is number greater, mass number is higher, that is for the first priority. First of all, what we say, just to see the atomic number, whether there is a higher atomic number compared to that other substituent, that is for first priority, for numbering. Otherwise, there is a same atomic number but different mass, that is nothing but for isotopes. Okay, okay. If we go to that, this molecule, okay, Cl, carbon, double bond carbon, here as a bromine, here as a hydrogen, here as for fluorine. First of all, if like this similar like molecules are given in that question, just to go to that numbering. That numbering is given according to that Kahn-Ingold Perlog rule. First of all, one by one carbons are substituent are given the number. See this carbon here, substitute chlorine and fluorine. This among chlorine and fluorine, a higher atomic number for chlorine as a 1. Okay, because atomic number increases, the priority also increases. That's why. So then next, there's a fluorine as a second. Then only we can move to that next carbon. This carbon is substitute bromine and hydrogen. From here, the bromine has a higher atomic number. That's why there's a 1. Hydrogen has a 2. So most of the students mistakes, they have considering entire molecule. Here there is a bromine 1 and then they go to chlorine as 2, like that. Actually there is a major problem, we doesn't go like that. So step by step we can follow the numbering, then only that question is a most accurate answer. So like this given number, after that the same number on the same side, that is for Z. Okay, there is a juice man. Z means juice man. Juice man means there is a same side. So similarly, another examples, I can return these molecules for changing that configuration. Okay, so here is a hydrogen, here is a bromine, here is 1 2 1 2, here 1 and 1 are opposite direction. That's why there is a E isomers. E means what? E, that is for ATG. ATG means opposite direction. So this is a most enough. Suppose sometimes the chain length or increases or a substituent of a atom or similar, we can go to that next level of atoms. Then next, at least any one stage the different atoms all came. There must be the different atoms all came, then only that is showing that geometrical isomerism. Okay, okay. These two categories are most enough for the geometrical isomerism, especially NEET and JE. If you want to that more and more advanced level clear explanation, just you can command in that video. Okay, so because sometimes some students are more willing. For that student, if you see this video, just you can command that more clear explanation or more examples. Okay, okay. Because there is a TRB and CSIR exams. There also it is most useful. Okay. The next, there is a geometrical isomerism is over. Next we go to that optical isomerism. Optical isomerism. Okay. So optical isomerism. Optical isomerism. Okay. So optical isomerism, there is a most condition. Molecules are must be chiral. Molecules are must be chiral. Okay, okay. Molecules are must be chiral. When that molecules are chiral, yes, at least the chiral carbon, at least a chiral carbon, at least a chiral carbon, and chiral axis, and that non-superimposable mirror image, non-superimposable mirror image. For this kind of conditions, if that molecules are presented, that molecules must be the optical active. It's simply saying the molecules are rotating the plane polarized right into that clockwise direction. That is for that dextrorotatory. If molecules are rotate the plane polarized right or anti-clockwise, that is for that L rotation. Okay, so it's for the general concept. In more detail, the molecular representation aspect, there is two types of molecular representation. One is for that Fisher representation. This Fisher representation, actually, here after that Kahn-Ingold-Perlag rule numbering, the lowest number or the least given numbering group, if presented, there is a fourth. This for that vertical line, or there is a this like that. Okay, so that is showing for clockwise means or D rotation. If they have given in that anti-clockwise, that is a L rotation. Okay, that is for L rotation. Suppose that is anti-clockwise. Suppose if that is a anti-clockwise are presented, there is a L rotation. Clockwise means there is a D rotation. Okay, so in case the least given number 4, there is a vertical line. Sorry, it's a horizontal line. So if like that, so here there is a clockwise rotation for after Kahn-Ingold-Perlag rule numbering. That is for L isomer. There is anti-clockwise means there is a D isomers. The most of that Fisher projection there is a in this type is covered. Okay. Then suppose the molecules are flying wedge method. Okay. There is a flying wedge method. Flying wedge method. Here, in generally that organic molecules of all carbon valency are followed by sigma bond only. That carbons are satisfying the sp3 hybridization. If sp3 hybridization, any two bond are on the plane, remaining two bond are off the plane. Let us see that off the plane, there is a fourth number is below the plane compared to that other. If molecules are representing like that, that is a clockwise rotation for D, anti-clockwise rotation, there is a L isomer. And similarly, there is a the fourth number is suppose given in the above the plane, there is a clockwise rotation for L isomers, anti-clockwise rotation for D isomers. Okay, anti-clockwise rotation for D isomers. So most of these two category are covered for NEET and JEE level problems. Okay, let us see that future video in this kind of topic covered problems, especially NEET and JEE level. Okay, then next, there is a enantiomer, diastereomer, and homomers. Suppose molecules mostly there is a chiral carbons presented, that is showing the optically active nature. It's a better to next video we studied for this enantiomer and diastereomer, because still now the video is very lengthy for seeing the subscriber as well as new viewers, most boring in this video. If the video length is very large or that is a boring, that kind of purpose, I avoid that that kind of boring. Okay, because education is a very enthusiastic pathway, that is the most healthy. That's why I'm saying we will see that tomorrow for the enantiomer, diastereomer, like that clear explanation. Okay, thank you to all. If you like in this video, you can subscribe and share your friends. Thank you to all.